The circle here has a radius of 10 centimeters, so from any point on the circle to the middle is 10 centimeters. And chord AB, right here, has a length of 14 centimeters. What's the distance from the center of the circle to the midpoint of chord AB? Well, you know from the chord properties that if we draw a line through the center of the circle to the midpoint of AB, we'll end up with a right angle, or yes, a 90-degree angle. So this will be 90 degrees. And we know that this distance is half of the total AB distance. So it's total 14 centimeters, so half of that will be 7 centimeters. And we know the radius is 10, so we can draw a radius from the middle point of the circle to point B, and that will also be 10 centimeters. Now we have created a right angle triangle where we know two of the sides. It's easy to figure out the third side. So again, using our formula for the Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the two legs, c is the hypotenuse, the long side, or the side opposite the right triangle. So let's just fill in our values. We don't know what a is, we know what b is. It's 7, and so b squared would be 49. 7 times 7. C is 10 centimeters, so c squared is going to be 100. And so we know that a squared is equal to, we can just subtract 49 from each side. That would cancel this out, leaving us with a squared. 100 minus 49 is 51. So we know what a squared is, it's 51. And we can determine a by doing the opposite of squaring, which is finding the square root. So a is equal to the square root of 51. Now 51 isn't a perfect square, so I'm going to suggest that you use your calculator to find the square root of 51. And you should round that off to 2 decimal places, so you should come up with 7.14. So this length here, from the midpoint of the circle to the midpoint of the chord AB, is 7.14 centimeters.